For more problems and videos like this for linear algebra, you can take a look at Sarai Studies. Link is in the description box below.
We're told to solve the following system of equations. We're given a system. The strategy is to rewrite it in an augmented matrix, A of B. These are A values, these are B values. And then get that matrix into row echelon form by performing Gauss elimination. And if I see that there's no solution, then I just stop there and say there's no solutions. But if I don't see signs of no solutions, then I keep going. And I get the matrix into reduced row echelon form so that I can rewrite it back into a system to get the solutions easier. This here is a system. Let's first rewrite it in a matrix. I always fill in the coefficients that are missing. This is 1, 1, 5, 2. And then an augmented matrix is just adding a line and then adding our B values, our ending values. These are A values or B values. That's why we call it our matrix A of B, where the B values are here, the A values are here. So this is this step right here, our matrix A of B. Now I have to get it into row echelon form. So remember, the first step is to start with your leftmost non-zero column. So this is my leftmost column that's not all zeros. So this is the column that I'm going to start with. The top position, the first entry, is going to be my pivot position. And then the third step is to kill anything below this entry. In other words, make it a 0. In this case, I want to kill this one and make it a 0. So here's how I say this. I want to kill something in row 2 because this one is in row 2. I want to use my pivot position that is in row 1. Then I just do add, and then whatever's here I'm going to put right there. So row 2. And then to find out what I actually need to do to get this to be a 0, I'm going to write these rows down here in order: row 1, row 2. So row 1 is 1, 5, 7. Row 2 is 1, 2, negative 2. Treat it as an equation, plus sign. Then I ask myself, what's the goal? The goal is to get this to be a 0. So that's the first value, needs to be a 0. Then I just focus on this column and I'm like, okay, when I add this plus this, how can I get it to be a 0? What can I do to row 1? I'm consistent, so the only thing I ever change is row 1, the row that contains my pivot. What can I do to row 1 to make this a 0? Well, I can just make it minus 1, and then so minus 1 plus 1 is going to be 0. So what I do to one value, I have to do to the rest of them, which is why we have to do it to the entire row. So I'm going to do a minus row 1, that's going to turn this to a minus, this to a minus, and this to a minus. And then I just add as always, so 1 minus 1, that's 0. This is minus 5 plus 2, that's negative 3. 7 plus 2, that's 9, it's negative, and then this, it's negative, and then this goes right here. This is my new row 2. So because the only thing I changed is row 2, then everything other than row 2 is going to stay the same. So row 1 is going to stay the same. And then row 2 is going to change from this to our new row 2. So now we look at our pivot position. Is everything below it 0? Great. Now we move on to the next submatrix form when we cross out the row and column that position is in. So then this is our remaining submatrix. And we repeat the steps again here. So we start with the leftmost non-zero column, that's this one, because it has an actual number. The first value in that column is our pivot position. In this case, it's the only value. There's no 0 in there, so we're good. And then we want to kill all of the entries below and make a 0, but there aren't any entries below it, so therefore we're done. This is in row echelon form. And we can check. Remember that the conditions for row echelon form is ZO. So are all 0 rows at the bottom of the matrix? There aren't any 0 rows here. So this is unapplicable, so it automatically passes. Does it pass a staircase hack? Well, again, you have to identify your leading entries for that. So your leading entries are the first non-zero number you see in every row. So you go until you see the first number that's not 0. That's this one, leading entry. Then you go to the next row. You go until you see the first number that's not 0. That's this one. So that's your leading entry. Then for the staircase, you start with your first leading entry and you go, and you only go down when you see your next leading entry, and then you go until you see another leading you don't see. So you just keep on going. So the staircase hack says, okay, we only want a height of 1 every time we go down, and we do, so it passes the staircase hack. And finally, are all entries under the leading entry 0? Well, this is a leading entry. Are all of the entries 0? Yes. This is leading entry. Are all of the entries under it 0? Well, that's unapplicable because there's no entries there. So it automatically passes that. So we've confirmed that this is in row echelon form. So this is where we are at this moment. Right now, I don't see anything that tells me that there's no solution, like something like this. This would mean 0 is equal to negative 9, and that's not true. That would mean there's no solution, so I would have stopped here and not have kept going and would have just said no solution to the system. I don't see any signs like that, so I'm going to continue on to converting this into reduced row echelon form to find out whether I have unique solutions to the system or many solutions. So recall, we started here and we went down and to the right. Now we're going to start where we left off, but go up and to the left. It's just the opposite. So we want to start with the last pivot position we had, which was this one. Then we want to do the opposite. Now instead of killing everything below it, we want to kill everything above it. First things first, we want to make sure all of our leading entries are 1. So we start with this one and want to make sure it's 1. Well, I would have to divide by negative 3. So what I do to one entry, I have to do to all of them. I want to change something in my row 2. And I just simply want to take row 2 and divide it by -3. So I'm literally taking everything in row 2, dividing it by -3. This still stays 0, this becomes 1, and then this becomes just +3. And since row 2 is the only thing I changed, row 1 stays the same. So 1, 5, 7, and then that is our new row 2. Great, now it's a 1. Now we want to kill anything above that and make it a 0. So I want to kill this 5. This 5 is in row 1. So I'm going to say, okay, I want to kill something in row 1. I want to use this pivot position to do so. That pivot position is in row 2, the second row. Then I ask myself, what do I need to change here in order for this to be a 0? Well, to figure that out, I write the rows in order. So the ones that are here, row 1 and row 2. So row 1 is 1, 5, 7. Row 2 is 0, 1, 3. I treat it as an equation, plus because that's what I see here. And then I ask myself, well, what's my goal? My goal is for this to be 0. That's 1, 2. That's the second one. So 1, 2. This needs to be 0. So then I focus on this column and I ask myself, what can I do to row 2, because row 2 is always the one that I'm changing, the blue, the row that contains my pivot position. What can I do to row 2 so that when I do this plus this, it's going to give me 0? Well, I'm really only focusing on this. This would need to be a -5. So to get this to be a -5, I would have to multiply the entire row by -5, because whatever I have to do to one value, I do to all of them. So it's going to end up being -5R2. So it's going to be -5, and then this is just going to be -15. And then I'm going to add as normal. 1 plus 0 is 1. 5 minus 5, that's 0, just like we wanted it to be. And then this is going to be -8. And then whatever's here goes here. This is saying, hey, this is going to be my new row 1. So the only thing I change is row 1. So row 2 stays the same. It's going to be 0, 1, 3. And the only thing I change is row 1. So that's going to replace my old row 1. Great. Now this is my pivot position. Everything above it is 0. So we move on to the next pivot position. We cross out the column and the row of that pivot position. What's left is going to be my matrix, and then you repeat the steps. Well, this is the first column in this matrix that I see that doesn't have a 0. The top value is going to be my pivot, and then you want to kill anything above it to be 0, but there's nothing above it. So once there's nothing above it, that just says, okay, you're done. You can stop now. So this is in reduced row echelon form, and we can check. So remember, ZO plus 1C, this makes sure it's in row echelon form, and then this part makes sure that it's in reduced row echelon form, because it's going to be in row echelon form, this, plus a little bit reduced, a little bit more, where all of the leading entries are 1, and all of the leading entries are the only numbers in its column other than 0. So we already know it passes row echelon form because we got into row echelon form. But are all of the leading entries 1s? Yes. Remember, leading entries are the first numbers, entries that you see that are not 1 in each row. So that's these. Are they all 1s? Yes. Are they the only actual numbers other than 0 in their columns? Well, look at the column. Is everything else 0? Yes. Look at the column. Is everything else 0? Yes. So it is in reduced row echelon form. So this here is our reduced row echelon form version. So remember, these are our coefficients. Each row represents an equation. Each column represents the coefficients that are being multiplied to these variables x1 and x2, and these are b values, just the values after equal signs. So I just copy the first row. So I do 1, 0, -8. I copy the second row, 0, 1, 3. And then these are being attached or multiplied to x1. So these go here, then x2, x2. These are equal signs. And then if they don't have a sign, it's a plus. So now I converted it back into a system of equations that is easier to solve. Because if you remove the zeros, you're left with this. And if you move everything to the right and then you remove the ones because they're insignificant, you're left with this. And what are you left with? Unique solutions. You have x1 is equal to -8 and x2 is equal to 3. So these are where these two lines intersect. So we found our solutions. So we managed to take a reduced row echelon form of our matrix, rewrite it back into a system, simplify all the jargon to find or extract our solutions so much more easily. We got unique solutions. Why unique? Because each variable has a unique value. In the next video, we're going to look at what it means for a system to have many solutions. So I'll see you then.